Okay, let's practice one more sample question. This time I'm going to use the number 3 question from the 2016 free response question. Okay, if you want to get the original package of the question, you can download it from the College Board website directly. Here, similar with the previous sample question, it has a graph on top, but this time we have graph of f compared to the previous one. Previous one was a f prime. Okay, so the figure above shows the graph of the piecewise linear function f for -4 to 12. Oh, now we have this g of x is 2 to x ft dt. Okay, once you have this one, you should remind the fundamental theorem of calculus part 2. If you do derivative of g of x, the g prime x will be just f of x due to that fundamental theorem of calculus part 2. We'll use it. Okay. A, does g has a relative minimum, relative maximum? Neither at x equal 10. So then to verify whether g has a relative minimum, maximum, neither at x equal 10, we need to verify the sign of g prime near at x equal 1. We'll do it, and that just giving the answer for A. B, does the graph of g has a point of inflection at x equal 4? To verify whether it's a point of inflection, we need to two-step down from g, so we need to verify g double prime, whether the g double prime sign is changing from positive to negative or negative to positive near at x equal 4. That's what we need to check for B. C, find the absolute minimum value and absolute maximum. Same thing, similar with the previous question. To find the absolute maximum, absolute minimum, we have to check g prime value, and we will check out the value. To get the actual value, we need to calculate the g itself, which is the integration of this f of x. D, from -4 to 12, we need to find the all interval for which g of x is negative. We just need to find out when the g of x graph is below the x-axis. But g of x is an integration of that graph, so the shape of the g of x itself should be totally different with this graph. That's the one thing that we should be aware of it. Okay, g of x. So graph, we have f of x. But g of x is defined by from 2 to x ft dt. So from f of x, we can find out g by integration. And if you get g prime x due to the fundamental theorem of calculus part 2, that is a d dx integral 2 x ft dt, that should be equal to f of x. Now, although we actually having f, if we have a question related to g, this f of x itself is same as the g prime x due to this rule. So that becomes exactly the same question like the previous one. Okay, we actually have g prime here. So this is g prime. So because this is g prime, the slope of f prime x from f to find out f prime, we need to slope of this curve, the straight lines here, that must be equal to same as g double prime. So remember for B, we need to check the point of inflection of the g. We need to check the double prime of g, which will be same as the f prime x. So we'll check the slope of this curve, right? Okay, so one by one, we will move for each question. See here, yes, g of x is 2 of x, so f of t dt here. One thing slightly different between this question and the previous sample question. Previous sample question actually giving one of the condition, what was f of -2 equals 7, something like that, right? But for this case, we don't have the value for g of x itself. But this equation already giving one important information. We know that if you have an integral, if the initial and final position of this interval are same, like 2, 2, then we don't have any area underneath the curve because we don't have any section inside. So that will be 0. That should be equal to g of 2. So automatically when you have this function defined using this integration, you can have this condition from this information itself. Okay, so we now have that given information, given condition as well. The G has a relative minimum, maximum, or neither at x equal 10. So at this point, we need to check G prime. If the G prime value changing from positive to negative, that means G of x is increasing, decreasing, so that will be relative maximum. If the G prime sign is changing from negative to positive, then it's a decreasing, increasing for G of x itself, so we have relative minimum of G of x at the same point. But if the sign of G prime doesn't change, then we don't have any either relative maximum or relative minimum. So how can we check the G prime? Because this f of x itself is G prime like we show here. So we just need to check whether the function is above the x-axis or below the x-axis. They both negative. Below the x-axis is nearer the at x equals 0, x equals 10. So that tells it's neither. Okay, G of x is neither a relative minimum nor relative maximum because G prime value is keep negative nearby at x equal 10. That should be answer for your A. Okay, let's move on to question B. Does the graph of G, not F, but G, have a point of inflection at x equal 4? Okay, point of inflection at x equal 4. So what we need to check, what happened for G prime x near x equal 4. And we just to find out, this is important structure for us, we need to check G double prime x to find out the point of inflection of G of x, but this one is the same as F prime, which is the slope of the graph. So where? At x equal 4, at x equal 4 here. Slope of this one is positive, this side negative, so that means at 4, G double prime x was undefined at this point because the peak doesn't have a slope, but the sign of G double prime is changing from positive to negative. So yes, this is the point of inflection for G of x. Okay, so G of x, G double prime could be 0 or undefined for the point of inflection. Okay, the most important thing to be a point of inflection is not actually having 0 or undefined at this point, but G double prime value should be, the sign of G double prime value should be flipping from positive to negative or negative to positive near at x equal 4. And we just to check it from this graph, okay? Because the G double prime, same as G of G prime, F of F prime, which is the slope of this curve. So we check it. So yes, the graph of G has a point of inflection at x equal 4 because of this. That's the answer for B. Now, we need to find the absolute minimum value and the absolute maximum value of G. So we need to find out the value of G. We know the G of x is the integration of f of t, so we need to find out area to find out actual value of the absolute maximum or absolute minimum from in this interval. Okay, so first, since we want to find out the minimum and maximum as well, we have to gather up all the points having local maximum or local minimum as well. And do not forget about endpoint. That's all we need to do. Okay, first, to find out the local maximum, local minimum of G, we need to find out G prime. Again, this is same as this graph itself. So we need to find out all the points make f G prime is 0. Among these points, we need to check plus minus sign flipping. So above, below, negative, positive, 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 negative, negative, negative. So this one are neither local maximum nor local minimum, so we don't need to worry about it. So this point will be negative, positive, so G of x will go down and up, so it's a local minimum, positive, negative, up and down, local maximum. Okay? So, but for here, we don't actually need to distinguish whether that is the local maximum, local minimum, so we will find out the both. Okay? So here, we just need to check G of negative 2, we don't need to check the 2 and 10, g of 6, and if including endpoint. These are all the points that we have to check. Okay, once you find out the value from there, the lowest value will be the absolute minimum and the highest value will be our absolute maximum. Okay, so absolute minimum and absolute maximum. Okay, so to check the actual value of g from f, we need to integration. Okay, so integration, we need the area of this one. So if you look at the actual coordinate, these three triangles are exactly the same, and this triangle and this triangle are exactly half of each triangle. So this is the 4, 4. So area of this triangle is 8, 8, 8. This one 4, this one 4. And here, g of 2, this point, g of 2 is actually 0. Okay, so from here going this way, you need to adding up 8 on g of 2 to find out g of 6. So g of 6 will be 8. And from g of 6 to g of 10, subtract 8. So that will be 0. And from there to go to the 12, we need to subtract 4 more. So this value will be negative 4. Okay? And from here, in opposite way, think about the value of g of 2, when you adding 8, that should be equal to 0. From negative g of negative 2, when you adding 8, that becomes a 0. That means this one should be negative 8. Okay? And here, from negative 4, from g of negative 4, if you subtract this area, that will be this value. Okay? So that means this one should be 4 units higher than g of negative 2, so we can find out this value. Okay, so if you actually can find out this area of the curve and is it adding up or subtracting, then you can actually get this value easily. Okay, if it is a little bit difficult to follow me when I get this value, then you can just actually build the equation. So starting from this value, so integral 2, 6, g prime x dx must be g of 6, g of 2. Okay, you can build the equation like this, and you can find out this area from the graph, and this value is 0. So you can find out g. So you can do similar things to get this whole values. Okay, now we need to find out what is absolute minimum and absolute maximum. See, this one is absolute minimum negative 8 when x equal negative 2, and this will be absolute maximum when x equal 6. That's the absolute minimum, absolute maximum value of g in interval this negative 4 to 12. Okay. D is a simple short question. If you actually got the right answer up to C, D, you cannot miss it. Okay. For D, for negative 4 to 12 interval, find all interval for which g of x is less than 0. Okay, when we actually examine the absolute maximum, absolute minimum on C, we actually got almost every value of g of x for the special point. And so from C, we found the value at negative 4 and negative 2, and this g and 12. These are the points that we found from the C. And this one is already found from here. And when we move from the 6 to 12, when at this 10, I explained their area exactly same, so that becomes a 0, 2. So I actually gather up all the value we already found up to C. Okay, so if you see this one, we know that g of x is continuous function. So the graph was negative and reach up to 0 here. So these are the parts that g of x was negative, and g of x actually becomes positive from here up to here, and after at x equal 10, the g of x value becomes negative again. So the question find out asking the interval g of x is less than 0 or equal to 0. So this this clearly we can see this one. So x value from -4 to 2 and x from 10 to 12. These are the answer for D. Okay, so from these two sample questions, what I want to emphasize to you guys is by understanding this structure, every question becomes straightforward. If you don't know how to find out the area, and if you don't know how to find out the differentiation, these are techniques. And now it's almost 1 or 2 weeks ahead from before the actual exam. If you guys don't know these kind of technique by now, you are in big trouble. Okay, I assume you guys already know these kind of basic already, and to approaching the question strategically, you need to understand the structure first, and by using your knowledge about the calculus, you can actually solve the question quite straightforwardly. That's what I emphasize this one. Okay, so I hope this video is helpful for you guys, and good luck for actual exam. Thank you very much.